Section 4.2, Externalized configuration. One build, multiple configurations. Property files bundled with the application source code are useful for defining some sensible defaults. Still, if you need to provide different values depending on the environment, you'll need something else. Externalized configuration allows you to configure your application depending on where it's deployed, while consistently using the same immutable build for your application code. The critical aspect is that you don't change your application after you build and package it. If any configuration change is needed, for example, different credentials or database handles, it's done from the outside. The 15-factor methodology promotes storing configuration in the environment, and Spring Boot provides several ways to achieve that. You can use one of the higher priority property sources to override the default values, depending on where the application is deployed. In this section, you'll see how to use command line arguments, JVM properties, and environment variables to configure a cloud-native application without rebuilding it. Figure 4.6 illustrates how the precedence rules work for overriding a Spring property.
Figure 4.6. Spring Boot evaluates all property sources according to a precedence list. In the end, each property will have the value defined from the source with the highest precedence.
Let's consider the catalog service application. First, you need to package the application as a jar artifact. You can do so from a terminal window, navigating to the project's root folder and running the following command.
See this code?
We're not relying on Gradle to run the application this time because I want to demonstrate how you can change the application configuration while using the same immutable jar artifact, that is, changing the configuration without rebuilding the application. You can run it as a standard Java application.
See this code?
You haven't overridden any properties yet, so the root endpoint will return the polar.greeting value defined in the application.yml file.
See this code?
In the following sections, you'll see how to provide a different value for the polar.greeting property. Remember to terminate the Java process, Control-C, before moving on to new examples. Section 4.2.1. Configuring an application through command line arguments. By default, Spring Boot converts any command line argument to a property key value pair and includes it in the environment object. In a production application, that is the property source with the highest precedence. Using the same jar you built earlier, you can specify a command line argument to customize the application configuration.
See this code?
The command line argument has the same name as the Spring property, prefixed with the familiar -- for CLI arguments. This time, the application will use the message defined in the command line argument, since it takes precedence over property files.
See this code?
Section 4.2.2. Configuring an application through JVM system properties. JVM system properties can override Spring properties much like command line arguments, but they have a lower priority. It's all part of externalizing the configuration, so you don't need to build a new jar artifact. You can still use the one packaged earlier. Terminate the Java process from the previous example, Control-C, and run the following command.
See this code?
The JVM system property has the same name as the Spring property, prefixed with the usual -d for JVM arguments. This time the application will use the message defined as a JVM system property, since it takes precedence over property files.
See this code?
What if you specify both a JVM system property and a CLI argument? The precedence rules will ensure Spring uses the value specified as a command line argument, since it takes precedence over JVM properties. Once again, terminate the previous Java process, Control-C, and run the following command.
See this code?
The result, as you can imagine, will be the following.
See this code?
Both CLI arguments and JVM properties let you externalize the configuration and keep the application build immutable. However, they require different commands to run the application, which might result in errors at deployment time. A better approach is using environment variables, as recommended by the 15-factor methodology. Before moving on to the next section, terminate the current Java process, Control-C. Section 4.2.3. Configuring an application through environment variables. Environment variables defined in the operating system are commonly used for externalized configuration, and they are the recommended option according to the 15-factor methodology. One of the advantages of environment variables is that every operating system supports them, making them portable across any environment. Furthermore, most programming languages provide features for accessing environment variables. For example, in Java, you can do that by calling the system.getEnv method. In Spring, you are not required to read environment variables from the surrounding system explicitly. Spring automatically reads them during the startup phase and adds them to the Spring environment object, making them accessible, just like any other property. For example, if you run a Spring application in an environment where the my_env_var variable is defined, you can access its value either from the environment interface or using the value annotation. On top of that, Spring Boot extends the Spring Framework functionality by allowing you to use environment variables to override Spring properties automatically. For command line arguments and JVM system properties, you use the same naming convention as the Spring property. However, environment variables have some naming constraints dictated by the operating system. For example, on Linux, the common syntax consists of having all capital letters and words separated by an underscore. You can turn a Spring property key into an environment variable by making all the letters uppercase and replacing any dot or dash with an underscore. Spring Boot will map it correctly to the internal syntax. For example, a polar_greeting environment variable is recognized as the polar.greeting property. This feature is called relaxed binding. In the catalog service application, you can override the polar.greeting property with the following command.
See this code?
Tip: on Windows, you can achieve the same result by running this from a PowerShell console. During the startup phase of catalog service, Spring Boot will read the variables defined in the surrounding environment, recognize that polar_greeting can be mapped to the polar.greeting property, and store its value in the Spring environment object, overriding the value defined in application.yml. The result will be the following.
See this code?
After testing the application, stop the process with Ctrl+C. If you ran the application from Windows PowerShell, remember to unset the environment variable with remove item env polar_greeting. When you use environment variables for storing configuration data, you don't have to change the command to run your application, as you did for CLI arguments and JVM properties. Spring will automatically read environment variables from the context where it's deployed. This approach is less error-prone and fragile than using CLI arguments or JVM system properties. Note: you can use environment variables to define configuration values that depend on the infrastructure or platform where the application is deployed, such as profiles, port numbers, IP addresses, and URLs. Environment variables work seamlessly on virtual machines, OCI containers, and Kubernetes clusters. However, they might not be enough. In the next section, I'll go through some of the issues affecting environment variables and how Spring Cloud Config can help address them.